In this session, we're going to talk about the roots of a quadratic equation. Okay, you know that the general form for a quadratic equation is just ax squared plus bx plus c. This should be equals to 0. And your c in this case is just the constant. Okay? Now, every quadratic equation that you ever solve, you get two answers. Now, let's say after you solve that quadratic expression, probably just get two answers or two roots. Let's say you get x is equals to 2 or x is equals to 1. Okay, now the question will be, what equation gave you these two answers? Okay, so now to find that equation, it will mean that we basically have to go back from the solutions to the equation itself. So now how are we going to do that? So we're going to take all these numbers back to where they were before we equated them to x. Okay, so x in this case would be minus 2, x would be minus 1, like that, and this whole expression is equals to 0. Okay, then if we are going to expand this, your x will multiply by everything in the brackets, and let's just do that. So we have x squared minus x. Now your negative 2 multiplied by everything that is in the brackets. Okay, what are we going to have? You have negative 2x plus 2 is equals to 0, like that. Okay, then let's put the like terms together. So you have x squared minus 3x plus 2 is equals to 0. So this is how we solve, and this is our equation. Okay, now this is when we're using numbers. Okay, now let's what if we say, how about if you want to come up with an equation that will just account for like every general expression when you're given two roots? Let's say after solving an equation, you find that your x is equals to, alpha. Your x is also equals to beta. Now in this case, alpha and beta, these are just the roots of the general equation that we earlier said, which is ax squared plus bx plus c. This is equals to 0. Okay, so now how are we now going to simplify that? So if we want to get back to the equation from where we got these answers, we're just going to say x minus alpha. Again, we're going to say x minus beta. Okay, this should be equals to 0. And if we do the same, where we multiply your x by everything that is in the brackets, what are you going to get? You're going to have x squared minus let me say beta x. Okay, then now if you multiply the negative alpha with everything that in the brackets, what are you going to have? You will have negative alpha x positive alpha beta is equals to 0. Okay, now what are we now going to have? Okay, so from here now, what are we going to have? We are going to factorize x here, like that, in the middle. And what are we going to have? We're going to have x squared minus, let's get our beta and our alpha. Okay, so what are we going to have? We're going to have a scenario where we have because there's a negative here, we're going to have when we factorize that part, we have alpha plus beta, then you have your x outside, it's the one that we factorize, plus alpha beta, this whole expression is equals to 0. Okay, now this will be the general expression or the general equation that you use to solve every or any quadratic expression when you're given the roots. Okay, so now what are we now going to have? What are we now going to have? So if we multiply this expression with a negative, are we going to get back to this? Okay, your x multiplied by, there's a negative multiplied by your alpha, you just have your negative alpha x, that is that. Then your x again multiplied by the negative multiplied by the positive beta, you're going to get a negative beta x. Okay, so that is just fine. Now since we're saying this is a general equation, let's rub here. Allow me to rub here. Now you know that from your general expression we said ax squared plus bx plus c is equals to 0. Now let's factor out a. So I'm going to factor out a to just be 1 over a. We'll multiply by 1 over a throughout. And what are we going to get? Your a and your a will cancel for the first expression. So you just have x squared plus, you just have b over a. Then you have ax plus c over a is equals to 0. Okay, now let's compare these two equations. The general equation that we've just found, okay, in terms of the roots, and this one that is coming from the quadratic expression. Okay, so you're able to see that here you have an x squared, even that one you have an x squared. These ones are equal. But now this has a coefficient of x, this has also a coefficient of x. So in this case, what are we going to say? We are going to say negative alpha plus beta will just be the same as beta over a. Then you're also able to see, if we compare the constants, looking at this one, c over a is just the same as alpha beta. We're also going to equate those ones. So you have alpha beta is just equals to c over a. Okay, now solving this one, solving the first one, you have when you distribute the negative on both sides, you have alpha beta, or alpha plus beta will just be equals to negative b over a. Okay, then on the other side here you just have alpha beta is just equals to c over a. Now these equations that I've written, it's a must know. You are supposed to know them. Okay, you are supposed to know them. Okay, so now let's put this into context. Let's say you have your general equation in terms of roots, which we've just said alpha plus beta. Okay, there's an x outside plus alpha beta, this is equals to 0. Okay, now if they give us, maybe if they've given us any roots, let's say they've given your x is equals to, let's say 1, or your x is equals to, let's say 2. So what you're just going to basically do in this expression, you write your x squared minus your roots. In this case 1 and 2, they will be adding. That's what this means. Secondly, your roots 1 and 2, they'll be multiplying here. Okay, so that's what you're just going to do to come up with the general equation. So what are you going to have? 1 plus 2, that will just give us a 3, then there's x outside. Okay, plus your 1 multiplied by your 2, that is just a 2, so this will be equals to 0. Hence, now if you're able to see from this expression, hence we're able to conclude that for us our general formula is will just be x squared minus, you're finding the sum of the roots. Okay, the sum of the roots, okay, x plus the product of those roots. That's now the simplified version of our formula for when you're solving roots like that. So you have to know these three equations, very important. The one that we just wrote, alpha beta is equals to c over a. Alpha plus beta is just equals to negative b over a. These three equations is a must know. Even this one is a must know, and the general one. Okay, now that we've known this, let's talk about something very important. When you're solving your quadratic expression, you can also use what we call the formula method, and the formula is just x is equals to negative b, negative b, positive or minus the square root of b squared minus 4ac, everything over 2a. Okay, now I must make mention that this in the root is what we call the discriminant. Now the discriminant just determines how the quadratic equation is going to, let me say, the direction in which it's going to go. Is it going to cut the x-axis? Is it going to cut the y-axis? All these conditions, they'll be dependent on what we call the discriminant. Now there are certain things that you are supposed to know. Condition number 1 is when your discriminant b squared minus 4ac, when this is greater than 0. This means that you only have positive value. Numbers that are greater than 0, they're just positive numbers, right? So when you have such a situation, and when you solve your equation, then you are going to have two distinct just to mean two different, okay, two distinct real roots. Okay, you must know that one. Then what if we say your discriminant, which is b squared minus 4ac, this is equals to 0? What are you going to conclude? This will just mean that you have one real root, only one real root. Okay, now the third condition is when you have your discriminant b squared minus 4ac, if we say this is less than, okay, if we say the discriminant is less than 0, those are negative numbers. Okay, so that will mean that you will have two complex roots. So you have two complex roots. So this is worth mentioning as we are going to be doing this topic. Okay, then if you are given a combination, let's say they've just asked you to find maybe just here we're just talking about distinct real roots and the real roots, but if in the question they say you have to find just real roots like that, what are you going to do? you're going to combine the two by saying your discriminant, in this case b squared minus 4ac, this will be greater than or equal to 0. Okay, this is another condition that you're supposed to know when they just ask you just real roots like that. Okay, now let's go back to our alpha and our beta expressions. Now let's talk about powers of these ones. Let's say if you have alpha squared plus beta squared, this is not, this is where most of the students make mistake. This is not the same as, it is not the same as, or it is not equals to, because maybe because of pressure you just write alpha plus beta, then you square like that. No, they are not equal. Okay, then another expression that you can say is alpha squared, minus beta squared. This is not equals to, okay, this is not equals to alpha minus beta squared. They are not equal. Okay, so you don't have to make this mistake. Okay, then now these are the key things that you're supposed to know in terms of powers. If they gave you the same one, alpha squared plus beta squared, okay, this can be simplified as, you're going to simplify it as alpha plus beta, okay, you square them, minus 2 alpha beta, like that. Very, very important. You can memorize this one, you can sort it. But now the thing is, how do you come up with this thing? So let's say you have our alpha plus beta squared. This, what is it going to be? So because what is it going to be in this case? If you've got alpha plus beta, let's say it's like that, then you square it, this, what is it going to give you? You realize that you are going to multiply 2 by alpha, so you have alpha squared. Again, what are you going to have? You're also going to multiply 2 by the beta, so you have beta squared. Then in the middle you are going to multiply 2 multiplied by alpha, which is 2 alpha, that again multiplied by beta, so you have 2 alpha beta plus, like that. Okay, now that we have that, what are we now going to do? We'll take this 2 alpha beta to the other side, and when we do that, you are going to have this expression where you have alpha plus beta, this is squared, minus 2 alpha beta that you took the other side. Okay, this should be equals to alpha squared plus beta squared. This is where the top expression is coming from. Okay, so that's how they came up with that one. So you might not need, but just need to know it, or let me just swatter, but I've just shown you how you derive that one in case you forget. Okay, they're just the same like that. Then another expression that you're supposed to know and understand is when you are given just alpha squared, let me say alpha if you're given alpha minus beta, then this is squared. What are you going to have? This is just the difference of two squares, right? You just alpha minus beta multiplying by alpha plus beta. Okay, that is worth mentioning. Okay, then what if we increase the power? Let's say alpha to the power 3 plus beta to the power 3. Okay, so the expression for this is just alpha plus beta Okay, this will multiply by the first expression that we had, so alpha squared minus alpha beta, okay, plus your beta squared, like that. Okay, so even this one you can still also solve it. Okay, so how are we going to solve this one? Okay, we are saying alpha plus beta cube root, like that. Okay, so what are we going to have? Let's simplify this. We see we're saying alpha plus beta, you know, this is multiplying by everything, alpha squared minus alpha beta plus beta squared, like that. Okay, so your alpha will multiply by everything that is in the brackets. Okay, your alpha multiply by everything that is in the brackets so that you find the answer. So when we do that, what are we going to have? We have alpha cubed minus alpha squared beta, okay, we have plus alpha beta squared. Okay, now on the other side, when we multiply the beta with everything that is in the brackets, okay, what are we going to have? You are going to have alpha, you are going to have alpha squared beta, okay, alpha squared beta, right? Yeah, alpha squared beta. You're going to have minus alpha beta squared plus beta, okay, this is just cubed, okay, cubed, like that. So from this expression you can cancel what is common. Okay, you're able to see that, you know, this is a negative, this is a positive, they'll just give us a 0. This is a positive and this is a negative, they'll also cancel and to just give us a 0. So in the end you're just going to remain with alpha, you know, to the power 3 plus beta to the power 3. Okay, so we've proven this expression. Now another expression that you need to know is what if you have a fourth power? What are you going to have if you have a fourth power? You say alpha to the power 4 plus alpha to the power, let's say the power 4, or plus beta to the power 4. What are you going to have? Okay, this will just be equals to, you know, you get the first expression that we had, so this will be alpha squared plus beta squared, okay, squared, like that, minus 2 alpha squared, okay, let me put this one in brackets, I'll say alpha plus beta, this is squared. So you're going to realize that the last one that we've included is that it is just the same as the first one that we have. Okay, it is just the same, but now what we've just done is we've just squared all the letters in the first expression, like that. Let's solve some questions. If alpha and beta are roots of a quadratic equation, x squared plus 3x minus 2 is equals to 0, find the value of 1 over alpha squared plus 1 over beta squared. Okay, so these are just fractions. So what are we first going to do? Merge these fractions into one single fraction. So we are saying we've got 1 over alpha squared plus 1 over beta squared, like that. So when we combine these ones, so our common denominator in this case, we just have alpha squared beta squared. Okay, when we divide the alpha into the denominator, what are we going to have? You're just going to remain with your beta. Okay, So the beta multiplied by 1 on top, just beta squared, plus the other okay, beta multiplied by the alpha squared, beta squared. Your beta will cancel, you just remain with your alpha. Your alpha multiplied by 1, it will just be alpha squared, like that. Okay, now you know that addition is commutative. Okay, commutative, I just mean if you say a plus b is just the same as b plus a, provided these numbers are no you rotate them if it's they're different, but you're maintaining the same numbers. Okay, so even in this case, we're going to have, let's rotate this one. We'll say alpha squared plus beta squared. It's just the same as what is on top, because we said it's commutative. Then down we've got alpha squared, beta squared. We can put these ones in the same bracket. We say alpha, beta, we put them in the brackets, then square them. Okay, now from the identities that we had, so for this expression, please don't be tempted to write because like we said, this is not equals to alpha plus beta, you know, squared like that. It is not, they are not the same. That's what we said, that they are not equal to. So you must not make this mistake. So we're going to replace by our expression or our identity. The identity for alpha squared plus beta squared, what did we have? Okay, so allow me to write here on top. We had, you know, alpha plus beta, okay, squared minus 2 alpha beta. Okay, now this whole expression divided by alpha, you know, beta, then there's a squared there. So now what are you now going to do? You're just going to replace alpha plus beta. You know that your alpha plus beta, when we're deriving those equations, we said your alpha plus beta is just equals to negative b over a. Okay, your negative b in this case, from your equation, okay, from the equation you're able to see that b is 3, so it will be negative 3 over, then your a is what? Is 1. Okay, so 1. So what will be your alpha plus beta? It will just be a negative 3. Then the product, alpha multiplied by beta, is just the same as c over a. Then your c over a, your c in this case is negative 2. So negative 2 divided by a, which is 1. So what are you going to have? You have a negative 2. So these are our products and our sum. So when we solve alpha plus beta, so we found that alpha plus beta in this case is what? We're saying it is the sum in this case is negative 3. Then this is squared minus 2. Then alpha beta, we've said the product is just negative 2 over alpha beta, which is the product again, to be negative 2 squared, like that. So now what are you then going to have when you solve that? Okay, so when you simplify this one, negative 3 squared, that will just give us a 9. Okay, negative 2 multiplied by negative 2, that is just a positive 4 over negative 2 multiplied by 2, that it's negative 2 squared. Negative 2 squared will just give us a 4. Okay, 9 plus 4, that is like a 13. Okay, so 13 divided by 4, that will be our final answer. Okay, let's solve another question. We're saying, given that the equation x squared plus 4x plus r is equals to 0, this one has distinct real roots. Find the range of possible values of the r. Okay, from your equation, they are saying x squared plus 4x plus r. Okay, so what is your a, what is your b, what is your c? Your a in this case is just a coefficient of x squared, which is 1. Your b in this case is just a coefficient of x, which is 4. And your c in this case is just a coefficient, or the constant, which is just r, like that. Okay, Now they're saying this has distinct real roots. Okay, what did we say about distinct real roots? The discriminant b squared minus 4ac, this will be greater than 0. Okay, so that's what that means. Now let's replace into this equation. So what is our b? Our b we're saying is 4, so it will be 4 squared minus 4. Our a we're saying is 1. Our c is r. This should be greater than 0. 4 squared, that is just a 16. Negative 4 multiplied by 1 multiplied by r is negative 4r. This should be greater than 0. When we take the negative, let's take the negative 16 to the others, the positive 16 to the other side. So we've got negative 4r. This is greater than negative 16. When we divide by negative 4 on both sides, we remain with r. Every time you're dividing by a negative and you have an inequality, the inequality changes the sign. So this will be r will be less than 16 over 4. 16 over 4, that is just a 4, right? Okay, in this case this will be the range, because they told us to find the range of possible values of r. R should be less than 4. Okay, this will be the range of values for which this equation is going to have distinct real roots. Okay, let's solve another equation or another question. We are saying, given that alpha and beta are the roots of the equation 3x squared plus x plus 2 is equals to 0, find the equation whose roots are 1 over alpha and 1 over beta. Okay, let's identify from our equation. We are saying 3x squared plus x plus 2 is equals to 0. So in this case, what is our a, what is our b, what is our c? Our a in this case is just equals to 3. Our b in this case is just equals to a 1. Our c in this case is just equals to a 2. Then every time they give you such a situation, always find the sum and the product in advance. Okay, so what are we going to have? We said alpha plus beta, this will be equals to negative beta over a. In this case, negative b over a. Your b is 1, so negative 1 over a is 3. Okay, so in this case this will just be our sum. Then our product, we say it's alpha beta. Alpha beta is equals to c over a. Our c in this case is 2. Our alpha in this case, or our a, is 1. So what are we going to have? We're just going to have a 2. Our a is 3 actually, so it is 2 over 3. So our answer is just to be 2 over 3. So now they're asking us to find the equation whose roots are alpha and beta. Okay, so let's find first the sum of this expression. We have alpha, the roots that we have, we've got 1 over alpha, so we are going to add plus 1 over beta. So let's find the sum first. So what will be the sum? You are going to find the common denominator, which will just be alpha beta. Okay, and when you do your alpha there, it just gives you a beta, so you have a beta plus alpha, like that. Then what are you now going to have? Addition is commutative, so you can replace this one. Say alpha plus beta, this is divided by alpha beta. Okay, now we've already found our alpha plus beta. Our alpha plus beta, we said, is negative 1 over 3. So this is dividing by the product. The product is alpha beta. Alpha beta, we found that it was 2 over 3. then you know from your arithmetic, when you have a division, it changes the sign, it becomes multiplication, the denominator becomes the numerator becomes the denominator. Your 3 and your 3 can cancel, therefore you just have negative 1 over 2. So this will be the sum for the first you know, for the roots that we've been given. Now let's find the product. So when we multiply these two, 1 over alpha multiplied by 1 over beta, okay, what are we going to have? 1 multiplied by 1, that is just 1. Alpha beta multiplied by beta, that is just alpha beta. Okay, so we're saying 1 will be divided by our alpha beta. We have found that is 2 over 3, and according to your division they will change sign. So what you are going to have, you are going to have 3 over 2. So this will be your second, you know, this will be your product. So we found the product, we found the sum. So what are we going to do? We're just going to substitute in our general expression. So our general expression, okay, allow me to wrap this part. So since the equation is asking you to find the equation, so the general equation, like we derived earlier, we said, you know, alpha squared is equals to the sum this x plus the product. Okay, this should be equals to 0. So we're going to replace, we're going to say x squared. What did we find as our sum? Our sum, we found that it was 1 over 2. Okay, it was negative 1 over 2. To multiply by that negative, so just gives you a positive. Okay, so negative 1 over 2x plus, then the product, we found that it was 3 over 2. This is equals to 0. So if you want, you can leave it here, or you know, you can distribute throughout by 2 just to remove the fractions. So if we distribute throughout by 2, what are we going to have? You have 2x squared. Your 2 and your 2 cancel, so just have an x, okay, plus your 2 and the 2 cancel, just have a 3. This is equals to 0, like that. So this will be your equation. Okay, thank you, see you in the next session.